Hi and welcome to the second Excel session. Today's agenda about pivot table, solver, data validation and how to create a drop-down list, histogram and regression. We may first start with pivot table. Pivot tables are one of the most powerful and useful features in Excel. With very little effort, you can use a pivot table to build good-looking reports for large data sets, where data can be arranged or rearrange statistics in order to draw attention to useful information. Although pivot table is a table of statistics that summarize the data of a more extensive table. This summary might include sums, averages, or other statistics which the pivot table groups together in a meaningful way. You can think of a pivot table as a report. However, unlike a statistic report, a pivot table provides an interactive view of your data. With very little effort and no formulas, you can look at the same data from many different perspectives. You can group data into categories, break down data into years and days and maybe weeks, filter data to include or exclude categories, and even build charts. The beauty of pivot table is they allow you to interactively explore your data in different ways. We can take an example to see how pivot table works. Let's say you receive these data sets and you need to figure out the total commitment amount by sales or renting machines and get them in order so you can see which machine generate the most income. The first thing you need to do before you insert a pivot table is to make sure that your data is organized in a proper format. This means it should be in a tabular format, where each column has a header, no empty columns or rows, and no total and subtotal rows. So to turn this dataset into pivot table, you have to select all those data and go up to the ribbon, insert and insert pivot table. In this box is where you select a table or range, and it's automatically Excel figure out it will create a pivot table from A1 to J28, and in this column come the data to the end. So if you add more columns, they may not considered in your end report, and then you have to update the range. What you need to do before you insert a pivot table is to turn the dataset into official Excel table. This has the added advantage that whenever you get new data added, the pivot table will automatically reflect that the moment you press refresh. So press cancel and go up to the ribbon, insert and insert table, or you can use the keyboard layout, Control T key, and Excel will automatically figure out that this table has a headers. So this box is checked, so okay. You can change the color, or maybe can use table style, but I will go for no color. So now as the table expands with new data, they will automatically be included in the pivot table. So to turn this table into pivot table, you can press wherever you like and go up to the ribbon, insert the table to new worksheet or to existing worksheet. I will go for existing. And the location will be here, or you can do it to the side, wherever you like. Oh, enter. So now as the table expands with new data, they will automatically be included in the pivot table. The pivot table does all the aggregation for you. without writing one single formula to do this. In the side here, you can get the pivot table field, and those boxes that define the layout of the pivot table. So now we can, for example, get into row the status and group name, and we can take the count of machine, and we can take to customer, and we can take to commitments amount, and we can in filter, for example, put the supplier. So here we can see if they are delivered or not delivered, the name of or the group of the machines: crane, large drilling machine, small drilling machine, truck, mixer, and count of the machines that the customer are rented or bought it as new. And we have the count also of the customer. And of course you can change, for example, the value of the customer. You can go for example, as sum, and we can see it change to 0. So we can go back, Ctrl Z. We can, for example, bring the we can see how many commitment amount for each group. We can, for example, also bring the machines. We can also, for example, bring the machines here, and we can see here cranes, if it's sold as new or rented. So if you would like to change this layout, you can, for example, put it in that way, and the field will be here and the boxes on the side if you don't have much space, or you can go to this layout. I'll go for default. And here the field list, if you want to remove it or to bring it back, you can also bring a pivot chart in which form you would like. For example, we can go for this one, or histogram maybe. Don't bring it. Okay, we'll go for this one maybe. Data, no, insert. Should be here. you can also bring, for example, a machine uh, up to the row to see uh, if crane or categories are rented or uh, sell it as new. And we can bring also charts to the recommended chart. You can go for this one. And here we can see the crane, small drilling, large drilling, uh, truck, and between delivered and not delivered. And of course here you have the arrow to decide what to show and what not to show. For example, this is for delivered and not delivered as only rented machine. So this and if you want to change, for example, this layouts by coming here and change it to this shape or to another shape, we'll go for this one. And wherever you press, it will disappear automatically. So we move on to the next subject. Solver. Solver is an add-in program you can use for what-if analysis. This Excel feature is for solving more complex problems that GoalSeek can solve for. So basically, Solver is for advanced GoalSeek. Because GoalSeek is just restricted to changing one single input, while Solver finds the optimal solution to a problem by changing multiple variables. Solver works with a group of cells called decision variables, or simply variable cells that are used in computing the formulas in the objective and constraints cells. Solver adjusts the values in the decision variables cells to satisfy the limit on constraint cells and produce the result you want for the objective cell. Solver, like GoalSeek, use an iterative method to perform its calculations. Using iteration means that Excel Solver tries a solution, analyzes the result, tries another solution, and so on. Yes, GoalSeek and Solver are both iterative, but that doesn't make them equal. In fact, Excel Solver brings several advantages to the tables. The advantage of Excel Solver is specifying multiple adjust cells. You can use up to 200 adjustable cells. Excel Solver enables you to set up constraints, also criteria, on the adjustable cells. For example, you can tell Solver to find a solution that not only maximizes profit but also satisfies certain conditions, such as achieving a gross margin between 25 and 35%, or keeping expense less than $200,000. These conditions are said to be constraints on the solution. And not least, seeks not only a desired result, but also the optimal one. You can use Solver to determine the maximum and minimum value of one cell by changing another cell or cells, and can also generate multiple solutions for complex problem. You can then save these different solutions under different scenarios. So let's take a look to how Solver looks like. you go up to the ribbon, data, and you find it here, solver. But first you have to activate the solver, and you go to the file option and adds in, and you can find the solver here, Excel adds in, go, and you check this box, analyze toolbar, and solver adds in, and press OK. But since I already activated it, so I don't need this one. So for example, if I want to change the percent of one of the ownership interest, this is a table shows Norway Group's shareholders. So I go to solver and set objective is the cell that I want it to change, and I will go for value to, for example, up to we can see 35%. By changing variable cells, or you can only select one cell, DT, so this one, and solve. So as you can see here, solver gave us this result, and if you are satisfied with the result, you press OK, and if you are not, so you check this box and restore the original values and go back. This box over here is where you add constraints, but in this task I won't add any constraint here, so we just do solve, and if we're satisfied with the results, so we go for OK. Let's take another example to see how solver can solve complex problems. Let's assume that we have a budget that's given to us for this project, and we want to allocate it between all these budget costs given special constraints that are defined over here. So over here I have all these production costs associated with each project, the fixed and extra cost, and it comes to this number. And I have budget cost, and I want it to be equal to this one. So we use solver to get the answer. Go to data, solver, and here we will define the objective cell that we want to change it to 1.4 billion. And which cell can we change? So we want the fixed cost should not exceed, and the extra cost should not exceed 2, and total cost should not exceed. But these numbers are calculated numbers, so to change them I have to change the main input, and the main input is the production costs. It's over here because the constraints are on total and not on production cost. So now I will add constraints, and the first one is the fixed cost, and should be less or equal to this number. And add. And the extra cost should not be exceed 2 and will be less than or equal to 900,000 and add, and the total cost should not exceed 2 and will be less than or equal to this number and add. So I will not change the method, solving method, and solve. So Excel solver found a solution, and we need to check first if our constraints are met. And we can see the fixed and extra cost are met, and the total cost are also met. And the total costs are also met. So basically I'm satisfied with the results, so I'll go for OK. So let's move on to the next subject for today, and we have data validation. Data validation is a feature in Excel used to control what a user can enter into a cell. Data validation can simply display a message to a user telling him or her what is allowed. Can also stop invalid user inputs. In addition, data validation can be used to present the user with a predefined choices in a drop-down menu. So let's move on to Excel to see how we can make data validation. You find data validation by going to the ribbon Data tab, and under this data tool you find data validation. You get a window with three tabs: a setting tab, input message, and error alert. In the first tab, setting tab, where you enter validation criteria according to your needs. There are a number of built-in validation rules with various options, or you can select custom and use your own formula to validate input as seen below. In input message tab, here you can define a message to display when a cell with validation rule is selected. This input message is completely optional. If no input message is set, no message appears when a user selects a cell with data validation applied. The input message has no effect on what the user can enter. It simply displays a message to let the user know what is allowed or expected. So you enter a title and input message, and make sure to check this box so a message will be shown. Here in alert tab, controls how validation is enforced. For example, when a style is on stop, invalid data triggers a window with a message and the input is not allowed. So we can take an example to how make a data validation. First, we will fill the train code column. So first two characters are non-numeric followed by 4 digits. There's two alternatives to make it. The first, go to data validation and select the text length, and here you get also various options, and we want to make it equal equal 2 or 6 or the number you like. So I come here and select the cell I want to make a data validation in, and go to text length and select equal to and 6 characters. So if I write 5 characters, LM 987, not accepted, and give me an alert message or stop message. This value doesn't match the data validation restrictions defined for this cell. Retry. So I will add the 6th character, and it's accepted now. So if I want to try the other way, and it is by making a formula. So there are also 2 ways. Either I go direct to data validation and insert or write a formula here, or I can make it like in this way, and I want to test this one. So equal that the number of characters are 6 characters. So I will use len formula, and the text, select the text, this one, and to test it I will make it equal 6. So it returns as true because it is 6 characters here. So to test the the last 4 digits are numbers. So I'll go for equal sign, and is number and the value, or instead of value I will use a quote sign and write the 4 digit, because this cell is combination of both non-numeric and numeric characters, so I will go for value is better. And I want to test the last 4 digits, so from the right, and as you can see here, returns the specified number of characters from the end of the text string. So select or tap and select the text, and the number of characters is 4, and close. So it returns as true. To test the first 2 characters is non-numeric, so I go for not, so change from false to true, or the opposite. Not number is number, and is number, and the value left, so can returns the specified number of characters from the start of the text string, and tap and select the text and the number of characters, and returns as true. So now it's time to copy those formula and lemon in the, or paste, sorry, lemon, paste it in the data validation. So I can do it by this way, by pressing Ctrl+C to get this clipboard, and if you have not activated it, you can activate it from the home page and clipboard and option, and check this option. So first I will copy, I will remove this one, clear, and copy this formula, C escape, and this formula, Control C and escape, and this formula, not the equal, Control C and escape, and equal and formula to check whether all arguments are true, and return true if all arguments are true. A logical test will be first len and comma is number, and no, not is number, and not number, and close. So I will highlight the formula and I will copy it, Control C and escape. So I will select the cell I want to add data validation, go to the ribbon data tab and data validation, and we can custom and input the formula, and okay. So let us test it. So L, M, and 3 digits. What? Okay, I think I made a mistake. Is this true? So what's the problem? It's because I applied it to 5 and not to 6. So I will copy Control X and clear and okay, and remove this one. And select custom, Control B. Now should work. So if I remove, yeah. So now tell me that this value doesn't match the data validation instruction defined for this cell. And I say okay. So if I write only one character with 4 digits, not accepted. So I can remove those formula and close this one. And if I want to add a message, so I can Control X and data validation to input message, just a reminder, and I can repeat it again in the error message. So now by selecting the cell, so the user can get a message that the first characters are non-numeric followed by 4 digits, and if they type a false argument or false number of characters, so they get the message here. And I can specify if I want the first 2 letters with a specific letters. So I will go back again to data validation and setting, and to the end of the equation, and comma and left, and left parenthesis and select the cell and 2, close it, and equal to quotes, let's see, ft so now it gave me alert message. So if I write ft 4-digit, accepted. If I change not ft, fo, so give me a stop message or try. So I'll go back for ft. So if I want to make data validation in all those cells here, I don't need to go and do one by one. I can only select it from the beginning and do the equation, or I can copy Control C and highlight those cells I want to fill data validation or insert data validation in, and right click and special, paste special and validation, and this will copy only the validation, not the value or the insert of this cell here. So now it's copied. As you can see, the message input messages are showing. So if I want to test it, ft 8763, so it's accepted, and so on. So I can make a drop down, and this is very simple. I can go to data, which is in another sheet, and I already make it here with the no problem. How can I remove trustee? Yes, I can just remove this one. Let's copy with, so delete. I can make employees as a head row, and I like to format cells, border, and font will be white and bold, make it 12, and fill with blue. Okay, so first I need to do is to make this as a table, and by selecting or highlighting the cells I want to make a table of, and you can press Ctrl T, or you can do it by go to the insert and make a table, and Excel will automatically assume that the first cell is a header. So okay, so here I can make a table name. I'll give the table name table EMP. Okay, so and then I have to define the name. So I go to the formulas, and define name or name manager. So I already here made one earlier, so I'll go for a new, and it's selected automatically. So remove it and come up here, and I have the table name here. So I can copy it, and okay, and close. So now you can see it generated. So I go back to the table and select the cell I want to insert data validation. Go to the ribbon data and data validation, and press or select list. So you can copy the formula in here, or by pressing F3. So you get this window, and you have all the names or defined names in here. So I'll go for employees, and okay. So as you see here, we get an arrow, and with all names in this table here. I can select, and to make the other cells with the same data validation, so Control C and select, and special paste validation, and okay. So you can see all those cells got ahead an arrow. So I want to make data validation for dates. And go back to the data validation and select dates, and you can choose between if we want to make it for on 1 year, so it should be we can make it greater than or between. We can go for between. So the start date, we can make it, for example, from the day of today, the 2nd of November to 2020, and the 20th of December 2020, and apply. Oh, okay, no problem. So if I make a previous or old date, for example, I can go for 20th of January 2019, so it's not accepted. If I go for 2021, not accepted too. But if I make the date of this year, say of December, make it 19th of December and 2020, and it's accepted. We can also make the time specific to, for example, we can time, we can make it greater than, for example, 05 a.m. press OK, and we make the arrival between, can make it less than and less than 12 p.m. or maybe 11 p.m. So if I make the early departure at 4 a.m. For won't accept it. I can change formats and over time make it look like region. If we make it 3 a.m. won't accept it. If we make the 7 a.m. we'll accept it, or maybe 13 or 1 p.m. we'll accept it. I can also specify the arrival time by data validation, and go to time and not between 1 a.m. and 5 or 6 a.m. and OK. So if I type 5 a.m. won't accept it. I'll go for 5 p.m. we'll go. And we can also make a data validation for stations from and to, just like we did with the employees. So select those cells and Control T, OK, and change name, station STN, and OK, and define name, formula, define name, and delete, and select, go to the top of the head row, and OK. So go back and data validation and list F3 and stations. OK. So now I have the head row. I can select which station I wanted the train goes from. For example, Oslo Central Station. I will copy the validation here. Special validation. OK. The same for this one. And special validation. And this one too. And I will highlight both because the same stations will go from and to. And special validation. Okay. So as you can see now, Lillestrøm and Oslo airport. And just to fill. Make it from Drammen. And here we go, we have filled table here. And you can make also a table of this data sets, and you can analyze it by using a pivot table. Insert pivot. For example, we can go for train code here, and go for name, and the departure time will go here. You can go for product, for example. No. Counts. I don't know why it's went up. If I change here, so it gives us the account, the count of departures for each employee, and we can take from and to, and maybe arrival time. Right. So yes, so we can move on to a next subject, histogram. Is a graphical representation and most commonly used graph to show frequency distributions. A frequency distributions show how often each different value in a set of data occurs. Also, plot quantitative data with ranges of the data grouped into bins. It has both horizontal and vertical axis. The horizontal axis labeled with what the data represents. For example, instance, distance from your work to home, while the vertical axis labeled either frequency or relative frequency or a percent frequency of probability. While bar graph, also called for bar chart, is a graphical display of data using bars of different heights. Bar charts are used to compare. So what are the two main differences between a bar graph and a histogram? A histogram is similar to bar graph, as we can see in this graph. But the difference is clear. A bar graph has gaps between the bins or the bars, and the bars of histogram has no gaps. Bar graph and histogram are two ways to display data graphically. Bar graphs are good when your data is in categories such as categories of films, comedy, drama, thriller, sci fiction, etc. But when you have continuous data such as a person's height, then use a histogram. Is good fit for. We can take an example to see the difference between bar graph and histogram. In this example, I will make a bar chart and histogram of this table. We have countries and export of product in different segments and the income. If I take only the income and make a bar chart of it, so go up to the ribbon, insert, and insert chart. We can go for clustered column. So we can see here that each income are classified in different categories, category 1, 2, 3, 4, and so on. So we can make adjustment to this chart, deleting this axis. Here you can see the plot area, and we can make or add serial labels. Maybe I will delete it, is better because it shows us the income, which is very difficult to see and we don't need. But if we can make another chart for histogram, so I'll take the same income and up to the ribbon and histogram, make some adjustment on it, can go for different color, and this is income, distribution, and double click on the vertical axis, so I get the format axis and axis options, and I can change the bin width or number of bins. I can make it up to 4, and I can change the overflow bin to 70 million, and change the underflow up down to 10 million. So while this chart classified the income in categories, histogram classified the income in ranges or frequency. So we can get add labels to see. We have 2 person who earn more than 10 million, and we have 10 person we have 2 person who or 2 countries who their income is less than 10 million, and 70 or 10 countries their income is higher than 70 millions. I can delete this one too. I can make another form of charts. I made table here and hide it, and hide. And hide. So if I delete this, these are the segments. We have 9 different segments, so I will use a formula to count how many countries export the same products. Go for count if y equal count if, and the range is this one, and comma, and the criteria will be ceramic. And by doing SL reference here, press F4 only one, so I can bring for fill out the table without change. Not this one. The range I should make a cell reference for. So you can see that didn't move. And I can make inserts and a chart for, or maybe and I can make a histogram for. So after I highlighted this table, I go to the ribbon, insert, and histogram. Control C. And make more than 2 bins, axis, bin width, number of bins, make it 4, and the overflow will be for example we can take 5, and the underflow will go for 2. So we can make it the chart title for segments. This and we can get add data labels. So basically here we have a 3 country which export ceramic and leather product, and homeopathy medicine. We can change the chart title to segment distribution. We can change the chart table to segmented distribution. And we can change the overflow and underflow bin. We can make the overflow for 5 and the underflow will go for 2. So there is add data table. We can also so as we can see here, there is 3 countries which sells the same amount of products but with different types, and they are 3 who sell more than 5 or export more than 5 products, and there is less than 4 country which sell 2 products, same amount of product but with a different type. As we can see here in this mini table, there is 1, 2, 3. There's 3 country sell or export 6 different type of products, as we can see here, and 4 countries, there's 1, 2, 3 and 4, which is less than or equal to 2, sell different type of products but same amount. We can take another example of how making a histogram chart. I have this example and it's overview over football player all around the world, and here I am interested to find the frequency of the weight. So in this table I will make a pivot table so I can find the frequency and then I can do a histogram analysis. So first I go to the insert and pivot table, and since I am already made this data set as a table, so therefore it's referred to table 3 and not to cell reference. So our existing worksheet will be here in this worksheet, and now I have the pivot table. And as I said, I am interested in to find the frequency of the weight, and we can find the count of. So right click, group, and I will copy this mini table and paste it here with only value. Do some adjustments. Here will be weight bin, and here will be frequency. Drag it down, select. Do some format cell. So take the highest number of this range and to calculate it against the main range. So now I'm ready to do a histogram or data analysis. So you can find a histogram by go to the ribbon, data tab, data analysis and histogram. Input range will be weight, alt, control and down, and all those cells are selected. And the bin range will be this, which one I calculated, and the output range will be in this cell here and with chart. So as we can see here that the frequency we found from the pivot table is exactly matches this frequency which pivot table histogram found. So if we make some adjustment to this chart and we can close the gaps between the bins, and we can put the compound type and with color black. We can make it more thicker. So this is a typical histogram chart with weight being in the vertical axis and frequency in the horizontal axis. And we can add some data labels, and we can see here there is 50% with weight 99 among 700 was, yes, 736 football players, and we have 355% with 78 in weight. So we can move on to our next subject, and it's regression. Is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by y, and a series of other variables known as independent variables. Linear regression is a data plot that graphs the linear relationship between an independent and a dependent variable. It is typically used to visualize how the strength of relationship and the depression of results, all for the purpose of explaining the behavior of the dependent variable. Regression helps investment and financial managers to value assets and understand the relationship between variables, such as commodity prices and the stock of business dealing in those commodities. There is two types of regression: simple linear regression and multiple linear regression. Simple linear regression is a regression model that estimates the relationship between one independent variable and one dependent variable using a straight line. Both variables should be quantitative and look like this graph. While multiple linear regression, also known simply as multiple regression, is a statistical technique that uses several explanatory variables to predict the outcome of response variable. This is a typical linear regression model where dependent variables are on the horizontal and denoted by y, and independent variables are on the x-axis, vertical axis, and denoted by x. Let's take a look for an example to how run a regression models. The first step is running regression analysis in Excel is to double check that the free Excel plugin Data Analysis Toolpack is installed. This plugin makes calculating a range of statistics very easy. It's not required to chart a linear regression line, but it makes creating a statistic table simpler. To verify if installed, so select data, and from the toolbar, if data analysis is an option as it is here, the feature is installed and ready to use. If not installed, you can request this option by clicking on the Office and option, and you get this adds in. So select Analyze Toolpack and Excel adds in and go and check the first box and go, and then you can find it again in data analysis here. So we can now run a simple linear regression. We can, for example, take the price indication with the quadrat meter. So we do it by go to data tab and data analysis, and regression and OK. So here we will define the ranges. We can take the sales price for dependent variables and the price induction for independence variables, and check for labels to make the first as header row and the output range will be here, and OK. So as you see here, running regression in Excel is easy because all calculations are performed automatically. The interruption of the result is a bit trickier because you need to know what is behind each number. For example, here in this part, we as you have just seen, running regression in Excel is easy because all calculations are performed automatically. The interruption of the result is a bit trickier because you need to know what is behind each number. Here below you will find a breakdown of 4 major parts of the regression analysis output. We can start first with summary output. output. We have the multiple R squared, adjust R squared, and standard error and observation. The multiple R is the correlation coefficient for measures or that measures of the strength and direction of the linear dependence between two variables. The correlation coefficient can be any value between -1 and +1, and its absolute value indicate the relationship strength. The larger correlation coefficient, the absolute value, the stronger the relationship. So +1 means strong positive relationship, -1 means a stronger negative relationship, and 0 means no relationship. So we have almost 98 correlation, or 0.98, and it's very big number. So they have a positive relationship, a strong positive relationship. We have the second key here, the R square, and it's a very important key because it is the coefficient of determination, which is used as an indicator of the goodness of the fit, and it varies between 0 and 1. 0 means a model has 0% explanatory power, and 1 means the model has maximal or 100% explanatory power. It is the model's correlations raised to the second. Is explain how much of the variation in independent variable can be explained also in the intercept, in the price indication, can be explained by the other factor in the model. The higher R square R is, the better the model. It shows how many points fall on the regression line. The R2 value is calculated from the total sum of square, and more precisely, it is the sum of the squared deviation of the original data from the mean. Also, the average. So this number is basically come from the sum square of regression divided on the sum square or total sum square. And it is exactly match. Adjust R square. It is the R square adjust for the number of independence variables in the model. We will use this key when we run multiple linear regression. So standard error is another goodness of fit, measures that shows the precision of your regression analysis. The smaller the number, the more certain you can be about your regression equation. While R2 represents the percentage of the dependent variables variance that is explained by the model, standard error is an absolute measure that shows the average distance that the data points fall from the regression line. And the observation number is the number of the observation of all data. The second part of the regression analysis is the ANOVA, and it's the second part of the output is And the second part of the output is analysis of the variance, ANOVA. Basically, it splits the sum of squares into individual components that gives information about the level of variability within your regression model. The DF it's and the number of the degrees of freedom associated with source of variance. The SS is the sum of square. The smaller the residual SS compared with the total SS, better your model fits the data. And this less or less than this one. While MS, it's the mean square. F is the F statistics or F test for the null for zero hypothesis. It is used to test the overall significance of the model. Significance F is the p-value of the F test. So of this one is the p-value. The ANOVA part is rarely used for the simple linear regression analysis in Excel, but you should definitely have a closer look to it. The significance F value gives an idea of how reliable statistically significant your results are. If significance F less than 5%, so your model is okay. If it's greater than 5%, you'd probably better choose another independence variable. And as we can see here, it's very small significance with minus 14. That means zeros, so it's very small. So that means it's we have significance F value, and our model is okay. The third part of regression analysis output, it's the coefficients here. This section provides specific information about the components of your analysis. The most useful component is the section is coefficient here, which is enables to build a linear regression equation in Excel, just like this one. It's advised to go and take a look to another variable which can make this model significant. So we will make a test if intercepts are equal to 0 or bigger than 0, to see if we can reject this model or accept it. So if we want to make a test to see if we B1 is equal to 0 or greater than 0, so we run a t-test. And the range will be sales and price induction. And we can test at alpha 0.01, also 1%. And the output range will be here. Okay. I forgot the labels. Okay. So here's the mean and also the average, variance, and correlation between those two, and it is identical to this multiple R. And we have the t-test and the critical one tail. Both those two are very important. By looking at those two values, the critical value and the test observator value or statistic observator value, we can see that the rejections array should be equal or greater than this value. But we got the t-test 3.0, which is greater than the critical value, so we reject the null hypothesis. Also, we reject this coefficient. And as we can see here, it's also greater than 0.01, also 1%. We tested this model for 1%. So we are confident 99% that the null hypothesis is greater than 0. So basically that was everything for today. I hope you enjoyed it and you find it educational and you did learn something from it. If you have any question regarding to those subjects I went through today, so you can just text me or PM me on Facebook. I'll be glad to help. So thank you very much and see you around.